You know, people talk a lot about atoms. They say tiny, tiny, microscopic, but nobody explains it like I do. So what is an atom? It's huge in importance, even though it's small. At the center, you've got protons, positively charged, very stable. They decide what element you are. If you change one proton, boom, different element. Neutrons, neutral. They're like the quiet people in the room. They add mass and stability. Too many or too few, and the nucleus gets shaky. And electrons, the little negative fellows, they buzz around the nucleus in clouds or shells. They make chemistry happen. Isn't that incredible? Now here's a question. If protons make the element, what does that tell us about identity, religiously or politically? But in atoms, identity is simple. Count the protons. Next, isotopes. Ever heard the word? Same element, different number of neutrons. Carbon 12, carbon 14, same carbon, different weights. So what does the average atomic mass on the periodic table mean? It's the weighted average of all the isotopes based on how common they are. Pretty smart, right? Very precise. Electrons have order. They occupy shells and subshells, 1s, 2s, 2p, 3s, and so on. There's a pattern, a beautiful pattern. Why does that matter? Because electron configuration explains behavior. Noble gases have full shells. They're stable. They don't want to make deals. Elements with 1 or 2 electrons in their outer shell, they're generous. They'll give them away. Or some will take electrons. That leads to ionization energy, how strongly an atom holds its electrons. High ionization energy, like the noble gases in fluorine, very hard to remove an electron. Low ionization energy, they lose electrons easily. Think about it. How does that influence real-world technology, batteries, medicine, materials? Electronegativity, the greediness for electrons. Fluorine is the greediest. It takes electrons like nobody's business. Atomic radius, how big an atom is. It shrinks across a row and grows down a column. Why do trends move that way? Because more protons pull electrons in tighter, and more shells mean bigger size. So I ask you, if we understand these trends, how can we design better materials, better medicines, better energy solutions? Isn't science about making things great again? Think about it.